Greetings everyone, and welcome back to the lesson. The subject is business data analytics. Today we're going to study data concepts, and by the end of this lesson you should be able to explain three data models. One being the conceptual data model. The second one is the logical data model. The second model is a logical data model, and lastly, the physical data model. Now, candidates, conceptual, logical, and physical data models are different levels of abstraction in data modeling that represent different aspects of data and its structure. These three. All right? They do what? They represent different aspects of data and the structure of data in data modeling. So the first one is conceptual data model. What is a conceptual data model? A conceptual data model represents what we call the high-level view of data. It represents the high-level view of data. The high-level view of data. The conceptual data model represents the high-level view of data without considering any technical details. It only focuses on the business concepts. It focuses on the relationships between the business concepts. And the main purpose of the conceptual data model is to provide a clear understanding of the data requirements and the business rules of an organization. Do you understand? Conceptual data model focuses on business concepts on the one hand and the relationships between the business concepts. And I've said that the main purpose of this model is to provide a clear understanding of the requirements, the data requirements, as well as the business rules of an organization. And this conceptual data model is always developed together with the stakeholders. All right? It is developed or created in collaboration with the business stakeholders and the subject matter experts. So that is a conceptual data model. Then we have the logical data model. Logical data model is a more detailed representation of the conceptual data model. Here, remember, we said it does not go into details. It does not get into the technical details. But the logical data models now expounds the conceptual data model by getting into the details, by getting into the structure of the business concepts. The logical data model defines the relationship between entities, between the attributes, the data elements, and so on. It gets into the nitty-gritties. It defines the relationship between entities, between the attributes of the business data and so on. The business data, the data elements, and so on. And it includes the constraints. It includes the the keys that govern the data. So candidates, the logical data model is independent of any specific technology or data management systems. All right? Then we have the physical data model. Physical data model is a detailed representation of the logical data model. It is a what? A physical or detailed representation. It is a detailed representation of the logical data model. It is a detailed representation of the logical data model that includes all the technical aspects of data storage, access, and such like. It defines, the physical data model defines the data types, it defines the storage formats, it defines the access methods. It also includes the physical location of data and the database schemes and so on. It is a specific, it is a model that is specific to a particular technology and a database management system. And in other words, candidates, the physical data model is a representation of the logical data model, which we say that expounds on the conceptual data model by getting into the technical aspects, giving the details about data. So candidates, in summary, the conceptual data model, I've said, provides a high-level view of the business concepts. Then the logical data model adds technical details and structures to this conceptual data model. Then the physical data model specifies the details of how the data is stored and how the data is accessed. How the data is stored and accessed. And candidates, these models, they do help to organize, they do help to document, they also help to organize data requirements. These models also ensures that the data is accurate, the data is complete, and the data is consistent. Those are very important aspects. All right? The purpose of having these data concepts or data models is to ensure that data is properly organized, data is properly documented, and data is accurate, data is complete and consistent, because it is on the basis of data that decisions are made in organizations. Now, before we close the lesson, I'm going to give an illustration of the three data concepts or models. An illustration. Now, let's say we are to design a database. Let's say we are to design a database to manage books at manifested publishers. Okay, database to manage books, or even a library at say manifested publishers. That's what we want to illustrate. We want to illustrate the three models, that is the conceptual data model and the logical data model and the physical data model. Now, the conceptual data model will first of all describe the high level view of the data, the high level view of the data, without getting into specifics of how the data will be stored or how the books will be stored. It focuses, the conceptual data model here will just focus on the relationship between different entities or variables, all right, within the database, as well as the rules that govern the relationships between the variables within that database. And in this library, for example, the conceptual data model might include entities such as books, conceptual, will include entities like books or variables like authors, all right? Books, we may have books, we may have authors, we could have entities like borrowers of books. We can have variables like the related publishers, and so on. Right? So the relationship between these entities or variables in this database, that is books, authors, borrowers, related publishers, and so on. The relationship, I'm talking about the relationship within this database, may include, for example, we may have a relationship like an author being able to write any book. An author can write any book. This is a relationship between different entities. Books is an entity, authors is an entity. There could be a relationship between these authors and the books, that an author can write any book. Or a borrower can borrow many books. An author can write any book. A borrower can borrow many books. Okay? An author can write many books. A borrower can borrow many books. That is a relationship. So the conceptual data model here does not define how the data will be organized or stored in this database. It simply defines what data is needed and how it is related. That's what we mean by the conceptual data model or concept. Then there is the logical data model. The logical data model. We are trying to illustrate a logical data model in a database to manage books or a library. So the logical data model here is more detailed, will be more detailed than the conceptual data model. And it will specify how the data will be organized, will specify how this data will be structured. It also may include things like it may be organized in, say, tables. This data can have details in tables, being presented in tables. It can be presented in columns. The data can be, in this database, can be presented in columns. We may have relationships between the tables and the columns, all right? The details on how this data will be accessed and organized. So the logical data model candidates might include tables such as the tables containing books, right? The tables of authors, the tables of borrowers, the tables of related publishers, and so on. And the books table, for example, the table that contains books may have columns such as the book identification numbers. We may have the book titles. We may have the author identities. We could have publishers' identities, and so on. So those are details. And the relationship between tables, the relationship between the tables containing books, containing authors, containing borrowers, containing the publishers, would be defined using different keys. For example, a book may have a foreign key referencing the author's table, indicating which author wrote the book, and so on. So those are now the details. Then we have the physical. Now, candidates, the physical data model in a database to manage books will specify the physical implementation of the database, the physical implementation of the database. And it includes information such as the file format. May have the file format. This is very important. We may have the storage media. It has to specify the storage media. There could also be information on access methods, the access methods. Okay, so the physical data model will specify the physical implementation. Here we say that a physical data model is a detailed representation of the logical data model. So the physical data model specifies the physical implementation of the database. And I've said it includes important aspects like the file format, the storage media, the access methods. And in this illustration of managing a library, the physical data model might specify that the database will be implemented, say, using MySQL, which is a structured query language. It is a structured query language, and that the books table, for example, the books table will be stored in a specific file in the database. This model might also specify the indexes or the indices to improve query performance, and also other details related to the database physical implementation. So do you understand this illustration of a database to manage books in a library? I've explained the conceptual data model. I've explained which is a high-level view of the database. I've also explained the logical data model, which gives now a detailed view of the database. It gives the technical aspects, the details of the data. Then there is the physical data model, which gives a detailed representation of the logical data model. So candidates, in summary, the conceptual data model, in summary, defines the data requirements. The logical data model, specifies how the data will be organized and structured. That is the logical data model. All right? Then lastly, the physical data model specifies the implementation details. Like in our case here, we've mentioned the details on the file format, the storage media, the access methods, and so on. All these must be specified in the physical data model. So that's all as far as the data concepts are concerned. Today we've studied 3 conceptual data models. The conceptual data model, and I repeat, the conceptual data model defines the data requirements. This one defines the data requirements. Then we say that the logical data model lays out the technical details, specifies how data will be organized, specifies how data will be organized and structured. The logical data model specifies how data will be organized, how data will be structured. Logic, from the word logic. And the physical data model will specify the implementation details. Specifies the implementation details. The physical data model specifies the implementation details. So that will mark the end of our today's session. But before we close the session, I want to refer you to the business data analytics practical paper that was done in December 2022. The first question under section 1 tested what we have covered in our today's lesson. I'm going to read this question. It says, data models evolve from conceptual, that is, a quick high-level view of the business requirement, to logical, where the entities involved are expanded and include more detail, and finally, the physical data model, which can be implemented with a specific database provider like Oracle, like SQL, like Server. The question goes on to read, which of the following choices is correct? A, the entire statement is true. B, only the statement on conceptual data model is true. C, only the statement on logical data model is true. D, only the statement on physical data model is true. And candidates, your answer is as good as mine, that the entire statement is true. Thank you for joining me in our today's lesson. I hope to meet you in our next session where we'll continue to share knowledge in data analytics.